In this slide, we are going to see integrated assessment model scenarios. Why this slide is important here is that we would be forecasting different levels of carbon dioxide under different scenarios. Integrated Assessment Model Consortium has developed a set of alternate pathways which they believe span the range of different futures of world, and based upon these narratives they have developed what is known as shared socioeconomic pathways, SSPs. Now these SSPs are SSP1, SSP2, 3, 4 and 5, and these SSPs differ in the amount of economic growth and the amount of climate safe energy that is being deployed. And the underlying assumption for these SSPs are the different amounts of carbon dioxide which gets emitted into the atmosphere each year, and using this, that is by inputting the different amount of carbon dioxide into a computer simulation model which is known as a global climate model or GCM, we get these outputs. So these outputs are SSP1, SSP2, SSP3, SSP4 and SSP5. SSP4 is not written here because that is not considered to be a practical scenario, but SSP1, 2, 3 and 5 are there. So if you see in this graph, the most widely used or the SSP which gives which predicts the least emission is SSP1, followed by SSP2, then SSP3 and SSP5. Now underlying working of these SSPs are representative concentration pathways. So that is the first level of working. These are also known as RCPs. So in RCPs, we construct RCPs by back calculating the amount of emission that would result in a given amount of radiative forcing. So the different RCPs are RCP 2.6 from RCP 2.6 to RCP 8.5. So RCP 2.6 is the RCP which is used generally as a proxy for reaching Paris goal, and RCP 8.5 is sometimes referred to as business as usual because this is the scenario which leads to highest level of warming, and based upon these RCPs then SSPs are formed. Now if you see in this graph, so in the first one it shows world's GDP under GDP versus renewable energy under different SSPs. So in SSP1, if you see here in SSP1, the percentage of wind and solar is highest, and GDP is at roughly around 600 trillions. In SSP5, GDP increases, but percentage of wind and solar is less than 60%. In the second graph, if you see, it shows the emission under different SSPs. So in SSP1, if you see here, so emission is decreasing and then it becomes constant. In SSP2, here if you see here, then emission is at the same level till 2060, and then it starts decreasing. If you see in SSP3, then emission continuously goes on increasing, and SSP5, so emission peaks up. In terms of carbon dioxide, in SSP1, the carbon dioxide level peaks up around 2050 and then it decreases. In SSP5, it continuously increases. And in terms of temperature increase, if you see here in SSP1, so it is aligned to Paris Agreement. So roughly the temperature increases around 2 degrees Celsius. In SSP 2 to SSP5, the temperature is increasing.